Down here, nothing dies quietly. In the deep ocean, a whale can live for a century, but when it finally falls, it becomes something else. A drifting mountain of flesh sinks into darkness, past the last blue light, past the reach of storms, into a world so cold and still it feels like time itself freezes. And then the feast begins. Not with teeth, not with claws, but with something far stranger. Something that doesn't hunt, doesn't chase, doesn't even have a mouth. Yet it can reduce a skeleton into dust. Imagine the biggest meal on Earth dropping like a meteor to the bottom of the sea. A whale fall. In an instant, the deep ocean floor becomes a city of life, a sudden, violent bloom in a place built for scarcity. First come the scavengers, sleeping sharks, hagfish, deep-sea crabs. They tear away the soft tissue with patient hunger. Then smaller creatures move in, tiny cleaners that strip every remaining shred. But even after years, something remains. A cathedral of bone, massive ribs, towering vertebrae, a skeleton that should last decades, even centuries, in the cold, slow deep. So why does it vanish? When scientists first sent cameras to whale falls, they expected to find the usual cast of deep-sea survivors, but what they saw looked unreal. A pale forest sprouting directly from bone. Not plants, not coral, worms. Thin red plumes rising like delicate flames, and beneath them something even more unsettling. Roots. Not metaphorical roots, actual root-like tendrils drilling into the whale's bones. And the strangest part? The worms had no mouth, no stomach, no way to chew, swallow, or digest, yet they were eating the skeleton from the inside. Scientists name them Osedax. It means bone devourer. But most people remember them as the zombie worms, because once they arrive, the bones don't stay dead for long. And this raises a larger question. How does an animal without a mouth feed on something as hard as bone? To understand Osedax, you have to forget almost everything you know about worms. Because Osedax isn't built like a normal animal. It's built like a living siphon. At the surface, those red plumes aren't decoration. They're gills, breathing organs, fanning out into the water to steal oxygen from the deep. But the real story is hidden below. The worm anchors itself to bone and sends down pale, branching roots that creep into tiny cracks, like fingers searching for a pulse. Inside those roots is where the magic becomes unsettling. Osedax doesn't digest bone on its own. Instead, it carries an army, millions of microscopic bacteria living inside its tissues. The worm gives these bacteria a home and oxygen, and in return, they break down the fats and proteins trapped inside the bone. It's like having a stomach made of living roommates, a biological heist. Because bone isn't just hard, it's a vault. Deep inside whale skeletons are rich oils and nutrients stored away like buried treasure. Osedax didn't evolve to eat meat. It evolved to crack the safe. And scientists still don't know exactly how the worm's roots dissolve and penetrate bone so efficiently, or what chemical tools its bacterial partners use to unlock that hidden energy. What we've discovered only deepens the mystery, because then we found something even stranger. Osedax doesn't just eat like an alien, it reproduces like one. In many species, almost every worm you see on the bone is female, large, rooted, powerful. So where are the males? They're there, just not where you'd expect. Some males are microscopic, tiny larva-like bodies that live inside the female's tube, like stowaways.
One female can carry dozens, sometimes hundreds, males reduced to almost nothing, just enough to make sperm. A life designed not for freedom, but for one purpose. It's one of the most extreme examples of biological inequality on Earth, and it raises a disturbing question. How does evolution decide when an entire sex can be shrunk into a living accessory? And there's an even bigger mystery beneath that. Osedax was first discovered at whale falls, but later scientists found it feeding on other bones too. Fish bones, bird bones, even ancient fossils, which means this lifestyle might be older than whales. So what did Osedax eat before whales existed? Scientists still don't know, and that question takes us deeper. The deep ocean is Earth's largest habitat, and we've explored only a small fraction of it. Whale falls are rare, but when they happen, they create islands of life in an otherwise empty desert. And Osedax may be one of the key architects of that ecosystem, turning bone into energy that can feed entire communities. But here's the unsettling thought. If you remove the bones too quickly, what disappears with them? What creatures depend on those slow, decades-long skeletons? How many species exist only because death occasionally rains from above? We've already found multiple species of Osedax, each adapted to different depths, temperatures, and bones. Some thrive in cold darkness, some in warmer seas. Some might be waiting on skeletons we haven't even discovered yet. And because whale falls are so hard to find, we may be missing entire chapters of life on Earth, hidden beneath the pressure. Scientists still don't know how common these worms truly are, or how many deep-sea ecosystems are shaped by them. In the end, the zombie worm doesn't feel like a monster. It feels like a message, a reminder that the deep sea doesn't waste, not flesh, not bone, not time. Down there, death isn't an ending, it's a doorway. And somewhere in that black water, beyond the reach of sunlight, beyond human maps, entire worlds are waiting, built on skeletons we'll never see. Because the deeper we look, the more the ocean whispers the same unsettling truth. We don't know this planet nearly as well as we think, and what we've discovered only deepens the mystery.